Okay, so just a little bit add on from just now. Sometimes the question will give you, this one is you here. It will give you it will say that a string is attached to the lift. Okay, so for this one, then you just do a little tweak. W is still the same. W equals to mg. And now instead of labeling R, now you label tension because you have a string here. Okay, tension, and then the rest is the same. The rest is the same, meaning that if the lift accelerates downward, so you have your net force acting down, so meaning that W has to be greater than the tension. Okay, so from your equation, F net equals to MA. F net is simply W minus tension equals to MA. Okay, so W is your mg minus tension equals to MA. Again, we take the mg minus tension is simply because mg is bigger than tension. Okay, so as a result, it moves down. Just want to repeat because back in that time, back in when I was in Form 4, this is the one that confused me. So I have to just stress and emphasize on it. Okay, so mg equals to mg minus t equals to ma. So tension equals to mg minus ma. So it's the same with the r. It's just instead of r we write tension. So it depends on the system. It depends on the case given. Okay. So you need to be, as long as you understand the concept behind it, then you are able to tweak and to change something like. You have to understand the concept behind it. Okay, now let's look at a few examples. Okay, we take a look at one example so that you get more clear for you. Okay, now let me pull this up. Okay, example 2.32. Okay, example 2.32. Subra stands on a weighing machine in a lift. If the mass of Subra is 55 kg, determines the reading of the weighing machine when the lift is stationary. Okay, now when the lift is stationary, what equations you have? The R equals to mg, right? Stationary, so it's balanced. There's no net force. So the reading of weighing machine, so you calculate R. Mass is 58, G is 10. So R equals to 580 Newton. That's it. B, if the lift is moving upward with a uniform velocity. Now, uniform velocity, constant velocity, same, is the same thing because there's no acceleration. No acceleration, no net force, so it's the same as A. R equals to mg. So equals to 580 Newton. Same answer. C, if the lift is moving upward with a uniform acceleration of 1 meter per second squared. Okay, accelerating upward. So which one we need to take? For accelerating upward, you have R equals to mg plus ma. Okay, so there's acceleration here. So this one you can put mg plus a. So mass is 55 and 10 plus 1. Answer is 638 Newton. And the last one, D, moving downward with uniform acceleration. Okay, it's the same thing. So use R equals to mg minus ma. So you can do your own derivation, or you can just straight away memorize this one. I don't recommend memorizing because I don't like memorizing. Okay, so you can kind of do your own revision how to get this one lah. So if you want to save time, of course, memorizing sometimes it would save time lah. Straight away you can write this one. Okay, so equals to m, so g minus a, and 58, 10 minus 1. So d you will get, if you calculate, you will get 522. Now, what do you notice about this one? When the lift is stationary or moving with constant speed, the reading on the weight balance is 550, right? This one AB, 550. When the lift is moving upward with acceleration of 1, so the reading is 638. So you notice that it increased, right? 它已经增加了. Meaning that this reaction force is the sensation that you feel. Okay? So meaning that you will feel you are heavier because R increased. And for D, 522 is decreased, right? So you feel that you weight lesser. Okay, in the lift. So that's how that's what it means lah. Okay, so this is just a simple example to show you this one. So when you do the exercise, there are many different kinds of example. Okay, now next. Okay, if you want to take a screenshot, then you just screenshot this one. Okay, next one. Now, we are done with the elevator. This one is pulley system. Okay, pulley system. So pulley system is where you see all this. You see this one, the frictionless pulley. Then you have object pulling another object together. All these questions is very typical. You see this everywhere. Very typical. So all this question is still in the forces of equilibrium, still in the forces of motion. F equals to ma. Okay. So whenever you see this one, then it is very much related to F equals to ma. Okay, now how do we do this type of question? Now, today I will teach you how to do this type of question. Okay, now, sometimes it can be very confusing. Sometimes it can be very simple. Just listen here. After you listen this lesson, you should have no problem in solving other. Okay, so if you have any question, just let me know. Now, a 1.5 kg trolley is being pulled by a 0.5 kg weight with the help of a pulley system. Okay, so you take a look at the diagram. Take a few seconds to understand the diagram. Okay, what do you see from the diagram? Just use common sense. Common sense you see from the diagram straight away. I think 是掉下去啦，是不是? Meaning that this one, the slotted weight will move down and the trolley will move to the right. Just use common sense. Okay. Now calculate the acceleration of the trolley. How do we do that? How do we calculate the acceleration of the trolley? Now, first thing that you want to do when you encounter this type of question is to see how many objects in the diagram, how many objects in the system. So for this typical system, there are two objects. One is the slotted weight and another one is the trolley. Okay, so when you have two objects, meaning that you have two equations of motions. I repeat, you have two objects, you have two equations of motions. You have three objects, you have three equations of motions. Okay, now let's solve it one by one. Don't look at the trolley first. Don't look at the trolley. We look at the slotted weight. Okay, I draw a box here. Okay, I draw a box. Focus on the red box. Yeah. Okay, focus on the red box. Now, label all the forces acting on this object. Okay, so first we have W equals to mg. This is the first force, right? What else do we have? Do we have reaction force? No. Why? Because it is hanging, no surface contact. So do we have tension? Yes, tension here. This is T. Okay, so other than outside the red box, we don't want to see it. Now, where is the acceleration? The acceleration is acting downward because it is moving down. Okay, acceleration acting downward, meaning that there is a F net acting downward, right? So how do we find the F net? For it to have a resultant force acting down, meaning that the weight has to be bigger than the tension, correct? The weight has to be bigger than the tension, meaning that F net is equals to weight minus tension. Okay, so F net is weight equals to minus tension. So from here, you use the equation, Newton's equation, which is F equals to ma. Now, again, you will use this very often. F equals to ma. Remember that F is F net, so it becomes W minus T equals to ma, and W equals to mg minus T equals to ma. And then from here, I express T in terms of mag, so T equals to mg minus ma. This is the equation of motion for this object. Okay, so this is the equation of motion for this object. Let me box it. No need box lah, like this one. I label already. So T, I write down on the left side here. T equals to mg minus ma. Now find the equation of motion for the second object. Okay, so now I erase this one here. I erase this one. 我找不到一个大的 rubber 可以插完，这个 rubber 很小个。Okay, now we focus on the second one. Look at the red box. Outside of the red box, we don't want to see. Label all the forces. Repeat the process. Okay, label all the forces. So trolley here, where is my mg? Always acting downward. W equals to mg. Now, since this trolley is on the table, right? It's on the surface, so there is a reaction force pointing up, and also there is frictional force. This one, F, is equals to 4, and also there is a tension force here, T, acting to the right. So you have 4 forces here. Now, work out the acceleration. Where is the object moving? It is moving to the right, right? It's moving to the right, meaning that acceleration is to the right. Acceleration to the right, F net is to the right. What is my F net? Equals to T minus F friction. In order to accelerate to the right, my tension has to be greater than the frictional force. So, which is why I write T minus friction. Other than these two, the reaction and the weight, no effect. Okay, the reaction and the weight, we don't care about it. Why? Because they are perpendicular forces. Okay, 它们是90度 they are the vertical. So 90度如果你去拿 r cos 90度它是等于没有啦。Okay, which is why we ignore it. We ignore the perpendicular forces. Okay, so to the left, to the right, so T minus friction only. So from your equations of motion, F equals to ma, T minus F, I write friction down here, F fric equals to F fric. Okay, now F frictions equals to ma. Now T equals to ma plus frictional force. Okay, so from here, substitute the value inside lah. So m is 1.5, so 1.5a plus frictional force is 4. So T equals to, this is your equation of motion number 2. Okay, so from your equation of motion number 1, again you substitute the value. Just now I forgot to substitute 0.5 times 10 minus 0.5a. So this is 5 minus 0.5a t. This is your equation of motion 1. Now, so I repeat, two object, so you have two equation of motion. Now, how do I find acceleration? It's in the formula. It's in the formula. So notice that the tension, okay, now you look at the whole system. Now you look at the whole system, notice that these two objects are connected by the same string here. It's the same string, meaning that the tension here and the tension here is same because they are on the same string. Okay, so meaning that this T and this T, they are the same. So you can substitute inside. Okay, you can substitute inside. So 1.5 again, 1.5a plus 4 等于5减 0.5a. I just substitute equation 1 and equation 2 together. So here now then you can calculate a lah, because only a left ma. A will be 0.5 meter per second square. This is your answer. Understand? Okay. So acceleration of the system is 0.5. So the slotted weight and the trolley will accelerate at the same value, which is 0.5. Okay. Why two of them same? Because two of them are connected ma. So one accelerated at 0.5, the other must be accelerating at 0.51. Okay. So I want to show you this method. Actually, this is method 1 to do it. The first method. You have the second method, which I will show you later. I want to show you this method is because I want to make sure that you know how to find the equation of motion of each object. Okay, sometimes the question will ask you, find the equation of motion of the slotted weight. Then you do like this. Or it can be find the equation of motion of the trolley. Then you do like this. Then only the next question, they ask you, calculate the acceleration. Okay, so this is method 1. This is method 1. Now, method 2 is easier. Okay, so okay, we are done now. We are done with method 1. So let me erase this one. Method 2 is easier. Now, method 2, let's quickly go through it. Okay, don't confuse. Now, method 2 is that we consider the whole system instead of one by one. We just look at the whole system. Okay, so if you look at this whole system, right, you can actually write it out like this. I can actually write it like this. This is the trolley. I label T. Okay, trolley, and then if I extend out the string, it actually looks like this. This is the slotted weight. I label W. Okay, so this is 1.5 kg, and this is 0.5 kg. Meaning that I just remove the trolley here. I just remove the pulley. I remove the pulley, then I extend. It looks like this. Okay, so this we consider this as a whole. So straight away we calculate F equals to ma. Now we know that the equation of motion is moving to the right. And sorry, we know that the motion is moving to the right. Okay, so meaning that the weight, the slotted weight here, it is the weight, right? So here is the frictional force. Weight is bigger than the frictional force. The weight of the slotted weight. Okay, so here the weight here looks horizontal, right? Actually, it's vertical because I write the diagram horizontally. Okay, it is actually acting down. Okay, so other than these two forces, all other forces we ignore it. Why? Because they are perpendicular forces, right? You have R here, you have another weight here. Okay, this one you don't have lah. Next is this one, you have tension here, and then you have tension here. Okay, but these two tension, they will cancel out each other. So we don't care about these two tension. So only forces left is W and F friction. So W minus frictional force equals to Mass is the total mass because you are considering whole system. So you want to take the total mass. So it is the 0.5 plus 1.5 and then acceleration. Okay, so weight is 0.5 times 10. This one is only the weight for the slotted weight. Minus 4 equals to 0.5 plus 1.5 A. Final answer, you still get 0.5. ms minus 2 is the same answer. It's the same answer. Okay, so this is method 2. It's considering the whole system. So you find which one suitable for you. Okay, or you can practice 2 of them. Okay, we are going to try one more example, and then you are off to your exercise. Okay, just one more example. Again, if you don't manage to take note, just watch back the video. I'll post later. Okay, because when I talk, right, after I write down this one, then I straight away I erase. Okay, maybe you not manage to take the note. Okay, second example, this one. Yeah, sorry about this one. This one looks a bit blur, but you can see, right? Okay. Now it's the same pulley system. Figure 2.130 shows a pulley system with 2 loads, A and B, connected by a non-elastic rope that passes over a frictionless pulley. Okay, so here it says non-elastic. So it actually nothing much. It's just that you have to you just ignore the elasticity of the rope. So elasticity has its own chapter. In the later chapter, we're going to learn about it later, not now. Okay, so non-elastic rope, just ignore it. That passes over a frictionless pulley. So there's no friction in the pulley. Okay, now take G equals to 10. Now, A, determine the resultant force of the system and state the direction of movement of the load. Determine the resultant force of the system. How do we find the resultant force of the system? Now, let's use method 2. We consider the whole system. Okay, 当你一看这个 system, you can straight away see that this will move down, this will move up. Okay, because it is heavier. Now, let's draw it out. Okay, so first I have lot A here. Then the string, lot B. Okay, lot A, lot B connected by a string. Okay, imagine I remove the pulley. I remove the pulley and then like this. Now, label the forces. So lot A, wait. Lot A, okay, there's forces acting to the left. You stuck. Okay, my pen okay already. So to the left, there is a force. What is this force? It is the weight of A, right? It is the weight of A. So weight is equals to 18 Newton. You just take the mass, then times 10. Okay, on the other side, load B also is the weight of B acting to the right. Okay, so the weight of the B is 12 N. Okay, you just imagine the whole system. 我打字它来看，所以18跟12也还是它们的重量来的。Okay, now in between this one, you have tension here, right? So what do I say? When you label tension, you label going out of the object. So it's pointing away from A. and this one is pointing away from B. Now you see that they are on the same string, meaning that these two tension, they will cancel out each other. They will cancel out each other. Okay, so cancel out each other, and so we don't have to care about it. We just ignore the tension. Okay, because they even out each other. So the only forces left is what? 18N and 14N, 12N. The only forces left. Now you know the motion is going to the left, right? Just now I labeled the arrow here, down here, and up here. So it's going to the left, meaning that your F net resultant force, F net is 18N minus 12N, 6N is equal to 6N. Answer. B, calculate the magnitude of the acceleration of the load. So you got resultant force, then you use F equals to MA. I write it on the left. F net equals to MA. So net force is 6N equals to, the mass again is the total mass, because now you are considering the whole system. It's the total mass. So 1.8 plus 1.2 and then A. Okay, so A should be no problem to calculate this one. Just mathematics. A, you will get 2.0 meter per second square. This is your answer for B. And this is your answer for A. Okay, so load A and load B will accelerate at the same speed, at the same state, because they are connected by the string. So if load A accelerate at 2, load B will also accelerate at 2. So acceleration of the system is just 1, 2.0. Okay, so what if I ask you, find the equation of motion of B? No, let me add a question here. Find the equation of motion of each object. Then you do separately. Lot A, we do lot A first. Lot A, again, you only look at lot A. So here, look at the red box here. Out of the red box, you don't focus it, don't look at it. Okay, so label the forces, just like just now we do. Label the forces, down, W, tension. Is there any other forces? No, just up, down. Okay, so since you know that it is moving down, so the F net is down. F net is F net equals to MA. Start from F equals to MA. So F net is down, right? So meaning that W minus T equals to MA. W minus T equals to MA. So mg minus T equals to MA. So T equals to mg minus MA. And T, I factorize out mg minus A. Notice that the M here is the mass for load A, not the total mass. It's the mass for load A. Okay? This is the equation of motion of load A. That's the answer. Load B, what is the equation of motion for load B? Erase this one. Again, we repeat the process. Look at the box, red box here, we only focused here. Okay, so again, label. So you have mass, W, you have tension, nothing else. But this one, the acceleration is acting up. So F net equals to MA. F net is T minus W. Because T is bigger, it's going up, equals to MA. So T minus mg equals to MA. T equals to MA plus mg, and T equals to M. I write M for load B, A plus G. This is the equation of motion for dot B. And these two T, they are the same value. Finish. Understand now? Any question? Any question, let me know in the chat. Okay, give me 2 minutes. I'll go to the washroom. Yeah. Okay, if no question, then I'm going to send the exercise in a group. Then you take the time to do it.